Okay, we're on to Unit 1, Section 7a. And this one's going to be on proportions and ratios, or ratios and proportions. You've probably done these before. We're now going to use them in algebra and do some algebraic solving. Okay, so there's a couple little notes I want to give you. The first thing is a ratio. A ratio is just simply a way to compare two numbers. It can be written in three different ways, and you'll see there's one way we prefer. You could say x colon y. You could say x to y. Or you could say x over y. Any of these are the ways to write a ratio. Okay? For example, let's do an example. If I say there were 5 dogs and 3 cats in the house, I could ask you to write a ratio of cats to dogs. The order does matter. So because I asked for cats to dogs, that means I have to have the number of cats come first, or in the numerator, and dogs second. So the couple things I could do 3 to 5. That would mean 3 cats, 5 dogs. I could write 3 to, the word to 5. Or I could write the fraction 3 over 5. Another thing I could ask you in this problem, I could ask you for the ratio of dogs to animals. Oops, I wrote ratio twice. Or dogs to total animals. Okay, so then you got to think about how many animals are total. If I have 5 dogs and 3 cats, how many total animals do I have that I'm counting currently is 8. So I would say 5 colon 8, or 5 to 8, or more usefully 5 over 8. Okay, so that's what we do with a ratio. And you've probably seen that before, and you'll see simple questions like that, but you want to make sure you're understanding them. Okay, so let's go on now. What we would do with a ratio is now we want to use that to write a proportion. All right, a proportion is an equation. Now we're going to make an equation stating two ratios are equal. Okay. Now when we have a fraction equal to a fraction, this is the only time this is true. People love to use cross multiplication. But the only time you can use cross multiplication is if we have a fraction equal to a fraction. Then we can use cross product. You cannot use cross product in any other situation. Not to find common denominators, not to add fractions. It's only if you have a full fraction equal to a full fraction. There's 2 different types of problems you can do with this. Okay, you can decide, so let's do example number 1 here. The first type you might get is, are these 2 ratios equal? Proportional is what we would say. Do these 2 ratios form a proportion? Now this one, you're actually testing to see if it's true. And we are going to use cross product, okay? So I'm just going to do 2 examples of this. So for example, I want to know, is 4/10 over 8/10 proportional, question, to 7/10 over 1 4/10? Now you'll notice I didn't say they were equal. I have a little question mark over the equal because I'm questioning whether this is true. Are these 2 the same proportion? And a quick and easy way to do this, now you could simplify each side, quote, reduce each side. I don't like to use reduce because we're not making it less. Or you can use cross product. So because I'm teaching cross product, that's what we're going to do. There's a lot of different ways to do this. So I usually do this. It's the top of one side times the bottom of the other side. So 0.7 times 0.8. And the reason I'm using parentheses is because of the decimals. I don't want to get confused with decimals and multiplication symbols. And remember, we don't use an X anymore to show multiplication. We're now in algebra. Top times the bottom of the other side. So 0.4 times 1.4. Now we're still asking the question of ourselves, is this true? If this is true, then the answer is yes, they're proportional. So I get out my calculator and I multiply 0.7 times 0.8, and I get 0.56 or 56 hundredths. And then I do 4.4 times 1.4, and I get 56 hundredths. Therefore, these two ratios are proportional. And notice how I showed that? I put a check over the equal sign. Now let me show you two that are not proportional. So I set it up. I want to know, is 6/8 proportional to 24/20? Now some of you already see this because you're not too afraid of fractions and you know how to simplify both of them. But let's say you're like, I don't remember, so I'm going to cross multiply. I'm going to do 24 times 8. This time I am going to use a dot because there's no decimals in this. 24 times 8, is that equal to 6 times 20? If it is, they're proportional. If it's not, this is not a proportion. Okay? Again, I get my calculator out and I get 192. 24 times 8 is 192. And 6 times 20 is 120. And that is not true. And so we put a cross through that. This shows not equal. These are not proportional. Okay, that's one type of problem you might come across. Proportional. Okay. All right. You don't have to write all that. You could just write the line through it. Now the other type of example problem is you might get something that's going to say solve the proportion. So if it says solve the proportion, we already know it's proportional, and then we can just use cross multiplication to solve a proportion. Okay, and this is going to use all those steps we learned about solving equations. We're just going to add another step to it. So let's start with the first one. I'm saying that x over 15 is proportional to 24 over 16. If that's true, which I'm telling you it is, then I can use cross product to solve this problem. So here's my cross product. I do 24 times 15. Now you don't always have to write the 24 times 15. I'm just writing it out so you can see what I'm doing. And then I'm going to do x times 16. I like the x after it, so I write 16x. x16 looks weird to me. Okay? And now I'm going to solve this. First step in solving equations. Are there anything that needs to be distributed? Are there any fractions we need to deal with? No. Second step, can we simplify either side of the equation? Well, yes, we can. 24 times 15. We can simplify 24 times 15 to 360. Okay, that's going to make it easier. Then the next step is, are there any addition or subtraction we need to do to both sides to get the variable by itself? In this case, there is not. There's no addition or subtraction in this problem at all. So then we do our final step. We divide. What do we need to divide by? Well, 16 is what's attached to the x, so to get it off, we're going to divide both sides by 16. I'm dividing both sides because that's the rules of algebra. Okay? And so then we get 360 divided by 16, and you get 22.5 or 22.5. And that's your answer. Okay? So again, not a lot of new stuff. We're cross product, and then we're solving an equation. Let's do two more examples. So the next example, I want you to pause and try this one on your own because it's very similar to what we just did. Now I know some of you might know the answer off the top of your head. You could figure this out without using cross product. The point of this is not the answer. The point of this is doing the process correctly. So if you could please pause it, do the process, and see if you get the correct answer. Okay, so here's what you should have done. You should have done 4 times 10, which is 40, equals 8 times x, which I want you to write as 8x. Then you should divide it both sides by 8 after you went through your checklist, and you should have got x equals 5. Or 5 equals x means the same thing. Okay? Now the last one, I'm going to add a little extra piece to it, part C. I still want you to try it. 5 over x minus 2 equals 3/4. I'm telling you these are true. I'm going to give you a hint. Before you cross product, put parentheses around this. That's the whole bottom. Now pause it, cross product, and use your rules of solving multi-step equations and see if you can get the answer to this. Okay, so what you should have done is 3 times the product, times the quantity, x minus 2, equals 5 times 4, which is 20. Now my first step in solving a multi-step equation, if there is any kind of parentheses, if there's any distribution, you better do that. So there is in this case. Now be careful, if you got this wrong, it might be you just forgot to distribute completely. So you should get 3x minus 6. Did you put minus 6 or did you put minus 2? Did you accidentally put plus? They're the kind of mistakes you might see. If you can find your mistake, you're understanding the concept better. Okay? If you made a mistake and you can find it, then you know what you're doing. Okay? Now we're going to deal with any simplifying on both sides. Well, there's no simplifying on either side. So now I'm going to deal with any add subtract that's crowding my 3x or my x. So I'm going to add 6 to both sides. And you get 3x equals 26. Now there's a reason I made this problem come out this way. Now, of course, you're going to divide both sides by 3. If you gave me a decimal that is a repetend, I will take a point off. A repetend is an estimated answer, as close as we can get without being the right answer. A repetend means it's going on forever and ever and ever. Well, you can't sit forever writing the numbers. So I want you to leave this, and I want you to start getting used to this, as 26 over 3. I will not accept a repetend in this problem. Okay? All right. So that is my first sections on proportion and